A while back, we proved the following theorem in an earlier video, that if we have phi is a ring homomorphism from R to S, then the kernel actually is an ideal of R, and the image phi of R is a subring of S. We actually proved this in two different videos, and I just want to, in this particular video, look at a corollary of that particular theorem. And the corollary says the following. If we have phi as a ring homomorphism from R to S, and we take a subring R prime of the ring R, then phi of R prime is also a subring of S, and in fact, it follows that phi of R hat is a subring of phi of R. And that's what I want to look at in this particular video, is the proof of this corollary. So let's get started. So we already know that if we take a ring homomorphism from R to S, then phi of R, let's get my notation a little bit clearer. Phi of R is a subring of the ring S. And what I now want to do is I kind of want to think about the ring R prime. So I'm going to say that we already know that R prime is a subring of the ring R. And so that says that R prime is a subset of R, and that R prime is a full-fledged ring under the same operations that R uses. So under the operations for our ring R. And what this means is that we can restrict the ring homomorphism phi to R prime. In other words, we can define phi as a map from R prime to S. And the question is phi still a ring homomorphism? Because if phi is still a ring homomorphism, then our big theorem will kick in and say that phi of R prime is a subring of S. Well, let's see. I know this. I know that if I take R1 hat and R2 hat belonging to R prime, then R1 hat and R2 hat also belong to R. And when I think about phi as going from R to S, we already know that phi of R1 hat plus R2 hat is equal to phi of R1 hat plus phi of R2 hat. And we know that phi of R1 hat times R2 hat will be phi of R1 hat times phi of R2 hat. But these properties also hold if we simply restrict our attention so we're going to restrict our attention to R1 and R2 hats that are only pulled from R prime. In other words, the fact that these properties work for any elements of R forces them to work for any elements of R prime. And hence, we do know that phi, taken as a restricted function from R prime to S, is a ring homomorphism from the ring R prime to the ring S. And hence, by our big theorem, that we reviewed at the beginning of the video, phi of R prime is a subring of ring S. And the only thing left to show is that phi of R prime is actually a subring of phi of R. So is phi of R prime a subring of phi of r. Well, let's see, they use the same operations because they use the same operations as S uses. And I already know that R prime is a subset of R, so if R hat lives inside R prime, then phi of R hat has to live inside of phi of R. And so what that says is that phi of R prime will indeed be a subset of phi of R. So hence we wind up getting the conclusion that phi of R prime is a subring of phi of R as well as phi of R prime is a subring of the ring S. In other words, we can draw a picture. We have S up here. Phi of R is some subset, is a subring of S, and phi of R prime is a subring of phi of R. So this is a ring, this is a subring of S, and this is a subring of both phi of R and of S. And that completes this particular video.